Hi, Chris Kuzmal here. Today we're going to introduce calculus by talking about what we have learned perhaps in physics, which talks about position, velocity, and acceleration, and limits, which is the first concept within calculus. So let's talk about Dasha the cat. How fast is your cat traveling? Well, if we were physicists, we might take some data. We might look at her position, look at the clock at a given position, and then conclude about her velocity. And actually, we immediately run into a clue that calculus is a thing when we look at her position and see she hasn't moved at all. The clock reads zero, and we want to know what her velocity is. And it's like, well, we're physicists, or we've been trained in science, maybe, and her velocity, therefore, is the rate times time, and that's it. Well, the rate times time is distance, so I can compute her. Oh, wait a minute, I don't really have her how long it took her to get where her clock reading is zero. I need two clock readings in order to get in order to get a time that has passed. And so I wait, say a second, and I check her position again, and I see her position is now at location 2 meters along, say. And so now I can compute how far she's traveled by taking the two distances or two positions. So I can get her distance from two positions, I can get her time from two clock readings, and then I can solve for the rate and get two. Yes, yes, all right, no problem. And as Dasha goes along, her position is 4, the clock reads 2. I do the math, her rate's still 2. It's all arithmetic. This is just trivial, no problem. I mean, who needs calculus? I mean, this is all great. Wait a minute. Her velocity, what if I measured her velocity after a half of a second and I find that she's a lazy cat. She doesn't move for the first half second. She just sort of says, I just have to get to location 2 meters down the road after 1 second. It's only been a half second. I don't need to move at all. And so we conclude that her velocity, well, we do the math, the same math we did before, and we get zero. Her speed was zero from here to here. That, well, so that sort of makes sense, I guess. And then, the next half second, she travels 2 meters, which means she must have popped up to 4 meters per second. And that's okay. I mean, the rest of the time, her velocity went back down to 2, I guess. So, well, so fine, but who needs calculus? I mean, let's just find out, though. I mean, I'm a little worried that Dasha might have changed her speed between that 1/2 second mark and the 1 second mark. And so I check at 0.75 seconds and I see that her position is 1. If I do the math now, it's all fine. The speed here is indeed, she's going 4 meters per second right here based on the math that we did before. And so everything's fine. It's fine. No worries. And, you know, uh, it's just like, well, what if she's decided to laze about again, but at some point, I can't tell whether she, so maybe we'll do another measurement. All right. Just the extra sure after 0.875 seconds with her, we measure her position, we measure the clock, and yeah, and it will, it'd be nice to do a few more checks though, just to be sure. So let's do another one, do another check, and it turns out all these numbers are good now. But how much more of this am I going to have to do to be really certain that her speed really is what I say it is? And this is where calculus comes in, because calculus basically says, well, the difference between these clock values, it might be getting smaller, but you just can't measure. You can't measure an infinitesimal distance between clocks if you're actually doing a physical measurement. Okay, but mathematics introduces these wonderful things called functions, which we can use to symbolically represent what happens as those clock differences get closer and closer